Okay, so this conference has been recorded, so just you're aware. And so, Sergio?
Okay, so this is about, this specific slide is about using Kubernetes instead of Swarm as the container management system. And there's several thrusts going on here. It's not just about Kubernetes, but it's also the ability to deploy VOLTHA without having to build it. Because today, the only way you can deploy VOLTHA is to download the source code, build it, and deploy it, which is for people who just want to run it a little bit of a pain. So one of the things we're going to be doing is making sure that there are pre-built public containers with a functional lineup that can be deployed and run under Kubernetes. Okay. We won't yet invalidate Docker Swarm support, but in the future we probably will. For the time being, we'll support both, so you'll be able to run both under Swarm or under Kubernetes. But at some point, we need to cut the support of this duality and go with one specific container management.
And it's pretty much right now. It's the other administrative thing.
Using help
to deploy person moving in is going on right now. So and I haven't I need to give my daughter an update.
We're going to try, and we're hoping for HA the split brain issue that we ran into using Swarm will be resolved once we start using Kubernetes. And that split brain is something we discovered early on during our POC3 testing. I believe David brought it on when we were doing our testing. And we're going to normalize container naming and tagging. And what's the state issue?
State issue is there is state behind containers. We want to contain
stateless containers.
But how do we maintain, I guess, recoverable state in containers? How do we fail over when there is, state? Where do we store state? Those issues have to be addressed when we move over to Kubernetes.
The split brain issue, I'm expecting like part of it's running in one instance, another part of it's running in a different instance.
Yeah, you basically come up with two containers that think they're the actual leader.
Oh,
okay, so you've got them both thinking that they've established leadership. It's an HA issue, and it was related specifically to console. Right. The problem with the split brain was a console issue, where you'd kill a server and bring it back up, and then instead of reestablishing communication and saying, okay, we're back as we've elected a leader among three, they'd both be running thinking that they were leaders, and that's bad. Okay. So basically, our approach is we've got a preliminary. And I'll let Ken provide any details that he feels like providing on this. But we've got a preliminary implementation using Kubernetes that's functional. It's not complete, but we've at least got some of it working today. I don't believe any of it's been pushed back into the repository yet, and we won't be pushing anything back until we're happy with it. So we've got two different people working on this. So David is working on the deployment of pre-built containers, and then we've got Rich on my team, Rich Jankowski, who's working on the Kubernetes deployment of VOLTHA, as well as the console to etcd transition. So Ken, do you want to provide some any additional details on our Kubernetes implementation? I know that it's still in progress, but it would be helpful for the people here to understand.
Yes, sure. Maybe I'll first start with talking slightly a little bit about the Docker Swarm experience that we had. What we find that any technology is great. When taken in isolation, they always work. if we run Hello World on Docker Swarm mode, it will never fail. Maybe David will find a way to break it, but in general it won't fail. What we find is the issues is really integration between Docker Swarm mode and the other services. And one of the services that we had issues with is really console. It's not that console is bad. Console is great. It works great, but console and Docker Swarm mode doesn't work together, and especially on failure cases. And that's how we saw the split brain problem. So given that, our approach towards Kubernetes is a pragmatic and agile approach. Basically, like instead of having a beautiful chart and says, oh, this is what we are going to do, what we are trying to do now is like do more a proof of concept. Take individual services, migrate each one of them onto Kubernetes cluster, see how it works. And so far what we have done, we have migrated the vOLTHA core itself, console, and also we have etcd in a new container there. We have migrated those, and we have shown that they work. We have tested it in our environment, and they work well. And the good news is, with Kubernetes, the split brain problem is gone. We don't see that, so that's pretty good. The other thing that we are doing with Kubernetes at this time also, we're looking at issues that we have seen with Docker Swarm mode, and one was the split brain problem, and we're trying to see how they behave in the Kubernetes cluster. So really our approach is really a pragmatic approach, and see what works with, instead of having a generic deployment strategy, we want to have a deployment strategy with vOLTHA services, like not any other services, but very specific for vOLTHA. And so once we'll have all those individual services migrated, we will move to the next stage, and where we'll put all the services running together in the cluster. Maybe we'll deploy them using Helm, and then we are going to perform like failure testing and see how they behave. We are going to use as the default KV store would be the etcd, will not be console, even though we are going to support it. Like we have modified the vOLTHA core to support either the etcd or the console. It's configurable, but in the test that we're going to do with Kubernetes, it will be Kubernetes and etcd. And what else I can talk about? In terms of the nodes, we're still having a free node cluster.
Hey Ken, hang on. There's a question.
Oh, okay.
So are you saying that console actually works okay in the Kubernetes?
Yeah, console works okay in Kubernetes. I tried the split brain with console and etcd in Kubernetes, and they both work well. What we find with console is the APIs that comes with console, especially the twisted Python APIs. They are not that responsive. For example, when a console node goes down, then it takes a while if we have a watch on it, it takes a while for that watch to get notification. However, the way etcd API is done, especially the etcd client version 3, they use gRPC in the backend. So whenever the etcd node goes down, we get notification right away. So there's in terms of performance there, etcd definitely is react better than console.
Thank you.
So have you tried etcd with Docker Swarm, and do you still see the split brain problem?
We try etcd with Docker Swarm, but we couldn't get it to work on Docker Swarm mode. In Kubernetes, we had to use something called etcd operator together with the core OS to make it work well. But we couldn't find a way so far to make it work on Docker Swarm mode.
Any others?
So with respect to, you'll still be using the config proxy and all that within the code, even with SCD, right? All that still remains the same.
Mm-hmm.
It's just instead of using the console key value store, you're basically using
The SCD key value store. Yeah, because console was initially because it supported DNS. And at this point, Docker Swarm mode provided DNS, and then now we can get the same functionality from Kubernetes. So we don't really need the additional functionality. Console also had the registrator, and you know, those are all things that you needed when you had a single mode vOLTHA without the services provided by the container manager. But at this point, the container manager provides all that. So all we're really using is the KV store in console. And since etcd, as Ken stated, is providing better performance, the preferred key value store is etcd. And since console is still supported, you can still run in swarm mode using console if you really want to. But I mean, at some point we need to. You know, for now, since this is a migration, it makes sense to support both as people migrate over. But at some point, I think we just need to, it'll get too complicated, and to simplify it, we probably need to cut out one of the container managers and one of the key value stores. In fact, the initial intent was that the key value store was going to be abstracted and you could plug in anything in the back end. But because of the poor performance that was being seen with console, I think a lot of direct calls were made to console without going through an abstraction layer. And that, in the end, is hurting us a bit now because it's a pain in the ass to replace it, which wouldn't have been if there was an abstraction.
Yeah, and that's part of it is kind of we're getting away from that in the sense of the coordinator service. Currently, like I'm trying to move it out of vOLTHA core. That's not planned for 1.3, but if we get it ready, it may be something that we could put in 1.3. So the coordinator service was very tied with console. It no longer is. And when it's run outside as a container, the other component of the data model was not tied to console. It has a layer, a KV store layer that abstract the store. So what we have done so far, we have created and we have been able to add an abstraction layer there for etcd. So we can have both of them in the configuration file.
It's a very, 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 very thin stretch.
Yes, pretty much.
Wait for soon.
Oh, break time.
So all the vOLTHA installers just
It's going to be updated.
Well, if you
make it more
if you tell me,
later also, not just the installer.
well, I mean, the installer itself doesn't have pain. It's the creation of the installer that's painful. The actual run of the installer is very simple.
You can get it to where it runs.
And I think to not.
Hi, could I ask a simple question? So, what is the HA? Hi, can you hear me?
Not really.
Not sure the speakers are.
I don't.
Okay, can you hear me now?
We'll be very quiet. Actually, no. So let's be quiet. So Tanasi, can you?
Okay. Well, I'd just like to ask a simple question. So, what is the HA scenario? What is the context? So, what is going down here? Meaning, what component is basically not available? So what are we?
Yeah.
Okay, I'm gonna type the question and then send it in. Okay,
That'd be great.
We can hear you now. I just didn't understand the question.
Okay, well, I'm just asking, what is the use case? What does HA mean in the context that we're talking about?
I don't think we're actually changing what HA means by moving to Kubernetes.
Yeah.
HA really still is fast failover. Sergio has proposed some HA.
For 2.0, it won't be. For 1.3, it will still be fast failover.
So Kubernetes doesn't change that story for HA.
Yeah.
The work for 2.0 does change that story for HA. Does that make sense?
In short, whatever we had in HA would still
Will still be there.
Will still be there.
It's essentially fast failover for 1.3.
Yeah.
Okay, thank you.
So when you say 2.0, what does it mean?
What do you mean? What does it mean? I thought 2.0 was defined release, right?
Right.
So for 2.0, we're going to change HA to be really HA.
Okay.
So it's going to be basically almost instantaneous, virtually instantaneous. So theoretically, a millisecond or so. There will be no waiting for the container to come back up. There'll be a release container that will take over immediately should something fail.
Okay.
And for read operations, it'll be instantaneous. I mean, there'll be multiple read containers running, and if all you're doing is making an API call to read, you'll get it right away. If you're doing a write operation, there'll be a few milliseconds of negotiation that need to take place before the.
Okay, thank you. That is the kind of answer I was looking for. Thank you.
So that's 2.0. Okay.
2.0, yeah.
And anything about anything on the Kubernetes side? So you listed the issues, right? The state.
So the more stateless the containers are, the better. And part of the disaggregation of vOLTHA that we're talking about, read-only containers versus the read-write containers, is all part of that, right? A read-only container is a database proxy. It's essentially stateless, right? So it can go down and back up, and there's no need to worry about which one you're making a request to, because they all have access to the same etcd database for their information. The read-write containers are a little trickier. They do maintain some state, so that's why our proposal is, that there's a primary and a backup of each one of those. And the reason they're stateful is because we've done load balancing across them, right? So not all OLTs are in every container, right? The load balancing is such that the OLTs are spread amongst all these containers. So those guys are stateful. So what David is talking about here in terms of stateless is let's make sure that as many containers as possible maintain no state. And
it's not related to Kubernetes.
No, it's not related to Kubernetes, but it's still something that we want to do. But no, it's not related to Kubernetes. We could have done this under Swarm.
Will be related to Kubernetes, I guess, if we have volume mounts or whatever. Kubernetes does that a little differently than Swarm, and that will have to be managed. Right. Well, we'll have to look at what all it is. But yeah, how Kubernetes handles secrets is a little different than Swarm. Those type of things that we'll have to deal with.
Okay. And then does it depend? So will the Ubuntu version will there be a dependency on that?
Well, I mean, we should decide for release 2.0 whether we want to. I mean, we're still on the same LTS version, right?
16.04.
Yeah, 16.04. I don't think there's a new LTS version that will be available between now and when we release vOLTHA 2.0. So we'll just stay on 16.04. When there's a new LTS release is when we have to decide, okay, what's the transition plan and what changes are required, if any, to go to the new Ubuntu release.
We'll have to lock in a Docker version, a Kubernetes version, and those type of things, Helm version, and select that.
Okay.
So there will be support for, I think you mentioned, all the knowledge related to Kubernetes, to pull up containers that have been that are in the registry somewhere, pre-built, so, you know. And I guess there'll be some sort of version control for them as well. And also the components that go inside that today, I think we know a few things that use Linux, and you can do that as well as a part of that. Or,
what do you mean?
There's a few dependency packages that we use that just go and pull the latest.
Not anymore. No. So I changed all that. All the Python versions, all the Python package versions are locked down to a specific version. I've locked down everything that the only thing that I can't lock down are the Ubuntu packages, right? The Ubuntu, the installer doesn't provide you any functionality to do that in any kind of simple way. If you try to do that, it becomes a mess, right? And you break the dependencies and things don't work. But all the Python packages have been locked down. What else did I lock down? I locked down everything I could, basically. So everything's at a fixed version. The only issue there is if suddenly a Python package becomes obsoleted, everything breaks, and you have to go figure out a new set of dependencies, which is not a walk in the park.
Right. I understand that. The locking down is only for build reproducibility, but when there is a new, much stable version available, we have to move to that. Like, for example, you're using 0.9 right now, because we lock it down so we could reproduce the same problem next time on that build. But then if there is 0.10 available, right, then we should probably go ahead and use it.
Yes, so that's a decision that needs to be made, and the question is, what are the enhancements that have been made in the new version, and is it worth moving now, or do we wait until other packages upgrade and then take a hit? So I think that the right approach, and this is my sense of this, the right approach is for every release, we should unlock it and figure out what all the new packages are, and then lock it down with the new lineup, and at that point do all the testing. And if nothing's been broken, great, we keep the new lineup. If something's been broken, then maybe we have to step back and say, okay, let's go back to the old lineup until either A, this problem is fixed, or B, we find an alternative lineup that's not the latest that will work. And so it's an exercise we need to do at every release. But I don't think it's an exercise we want to do multiple times during the release, right? Once we settle on that, and it should be done early enough that we get plenty of testing in. Because if you wait till the last week of a release and say, okay, let's upgrade all the packages, we might be in trouble.
So that should be part of the system integration test, right? Or even before the system integration test?
My view is when we open up a new release, one of the first sprints should upgrade all the packages that we're using to the latest, and then lock them down at that level. And then everybody's using the new stuff for all the development cycle, and if there's going to be a bug found, it'll be found during development. Somebody will start going, oh, this used to work, it's not working anymore, what's going on? It gets tracked down to a Python package, and that one needs to be stepped back to whatever working release exists. The only problem is it's a mess, right? Like, it's really ugly. Like trying to line those up so that they work is not as simple as it might seem, because they have dependencies between each other, and it's quite the exercise to get that to work.
So Saurav, from ONF, is that for other project within the ONF, is that the common practice? When unlock it, all the dependency, and then the searcher just explained.
It varies from project to project.
Okay.
I don't have a concrete answer, but what Sergio suggested seems okay to me.
Okay.
I mean, the earlier we do it, the better, if we're going to do it at all. I mean, the other option is we know it's all working at this level, so let's never change it. But the problem is, eventually somebody's going to obsolete a package, and then we're going to have a huge headache down the road.
The core has run into that.
Yeah, because things have changed so drastically that nothing works anymore, and you have to go make a bunch of code changes to adapt to the latest versions of the packages. So
you're saying every release should have a story to what the next stable version is. Yes.
And not only that, it's upgrade the packages, and it code changes are required because something changed in the library, those need to be made as well in the subsequent story, right, in the next sprint.
No, so the community as a whole need to be able should evaluate what being introduced. You know, when you unlock it and then update all the packages, I think the community on the whole should be able to work on that together, right? So,
well, I mean, somebody needs to go through the exercise of checking out all the dependencies and making sure that the lineup of packages is viable and will compile, right? And you don't get all these Python errors about, whoops, you know, you're using a wrong level of a package here, expecting this and that. So once that's done, then everybody in the community needs to run through their integration tests and make sure that that change hasn't broken something, right? And if something's broken, then there's two choices. One is track it down, figure out if it's a bug in the library or just a change to the library that requires a code update. And if it's a bug in the library, then that one needs to be moved back. And if that one's moved back, then you need to find all the cascading reversions that you need to make to get back to a working state. And if it's a code change, then we should agree that the community owner of that code needs to make the change to adapt to the new library.
I guess that's the problem. The open source project will probably all different. Yep. Yeah, they all have to.
Not a new problem. Not new.
Golang has fixed that, by the way, by using the ugliest mechanism that I've ever seen.
Versioning in Golang is a
versioning. It downloads all the source code for all the packages that you depend on, and you build your own copy of it. And that way, you know that you submit that to the library to your code base. So David here has submitted more code than anybody.
So when we use number of lines,
no, that's no longer valid.
So can I use that to determine who has a better contribution?
That's better. That's a qualitative.
You can write 3 lines of code in Go and submit 20,000 lines, right? So.
So are we also, based on this, are we also address the database issue? Or is there additional database?
Well, I mean, so you're talking about SD, right? So we are, as part of this, we are, as Ken explained, right? Mm-hmm. We're going to standardize on etcd because it has higher performance than console using Kubernetes. It's got a gRPC interface or a gRPC API. So that's the plan. But as Ken also stated, we're not going to stop supporting console right away.
Right.
And mostly because if we're saying we're going to support Kubernetes and Swarm, and we can't get etcd yet to run under Swarm, then your only option is to use console.
Sean, is your question about are you still going to support binary database or are you going to support that's something outside? Moving to etcd doesn't change the format in which.
No, it won't change the format.
So that's a different topic.
I mean, how many databases we have in the VOLTHA, right? We're going to have all these kind of databases, right? So what is this database?
So etcd is a key KB store, right? It's a key value store.
Okay.
And everybody's welcome to use the same KB store for all data. And in fact, I think it should be encouraged that we don't start. So let me retract that. Sometimes there is a need to use a relational database because it provides a lot of functionality and power that will simplify your code immensely, right? Rather than using a straight KB store. But if all you need is straight KB type functionality, then I would say, let's agree that everybody uses the existing Kubernetes, the existing etcd database for their key value pairs. If there's a need to use a different type of database technology, like relational, then we need to decide whether MySQL or Postgres or whatever's out there is better suited for that implementation, but I didn't see any databases yet in what we've looked at that required anything other than KV store at this point.
So like OpenAPI gets a database over there, right?
Yeah, but that's the 558, only Class 5A and 5A.
So I guess you have a session on NetConf, right? Maybe that's something to touch upon again when we out there, because you need to be able to retrieve and change.
Yeah, so that would be more. Well, you can retrieve and change from a KV store. It's just more complicated if you're.
It's complicated.
Queries are complicated, right? It's yeah, I agree with you that if there's a requirement for a different database type, then we need to decide what's going to be used and how we go about that. And I mean, everybody's got their favorite relational database. It's a religion, actually. We'll cross that bridge when we come to it.
Okay, and let me see. Any questions locally? Oh, you have more?
No. Well, I have some stability enhancements for HA that I wanted to talk about, but I think we discussed it.
There's also a separate section intended for that.
Oh, there is? Okay. Well, then we'll wait for that.
No, we can just talk about that here right now.
So you want to talk about the stability enhancements?
Yeah.
So basically, there are some HA enhancements that we want to make, and we've discussed some of them, right? Like the use of etcd, the use of Kubernetes. One that I talked about earlier, and so did Ken, was the disaggregation of the vOLTHA core. The vOLTHA core performs a multitude of functions today. So what we're doing is disaggregating that. So there's the coordinator. So the coordinator function, the adapters, right? There's a bunch of disaggregation that needs to happen there. So the adapters we knew about, right? So we're going to take the adapters out and put them in their own containers. But there are other things. So we're going to take the coordinator. Today the coordinator manages the coordination between all three vOLTHA cores, and it does things like it receives a request if the container that received the request has the data, then that request is processed directly within that container. If the container that received the request does not have the data because of load balancing, it's put in a different container. The coordinator forwards the request to the other container, which then processes it and returns it back. But the other thing the coordinator does is that if there is a list request that requires information from all containers, it broadcasts out the request, receives all the responses, aggregates all that, and sends it back up northbound. It also handles the election of mastership and all that other information. So the coordinator is going to be extracted onto itself, right? To help with statelessness of containers. So I talked about another one earlier. Read-only requests will go to a specific container that does nothing but service read requests. So that container is completely stateless. It's just a database proxy. It gets a request, goes to the database, gets the information, and returns it. It doesn't matter which one in an HA implementation. It doesn't matter which one gets the request. They can all respond to it. The read-write containers, as I said earlier, are a little trickier because those guys each have a portion of the OLTs. Not all of them have all the OLTs. In which case, there will be primary and backup containers, and if the primary fails, the backup will take it. And finally, the final one that is in here is choose a KV store with a client API that's more responsive. Well, we got the answer to that earlier, which was etcd was a lot more responsive than console. Because it uses gRPC, and so your state change notifications are much quicker, and that's important. So and I'll tell you why. So let's say a container goes down. The proxy, everybody was using state changes, but the example that I'm most familiar with is the proxy is waiting for state change notifications on a specific key, so that if a container goes down, it reduces its set of cores that it can communicate with. Let's say you have 3 cores running, one of them goes down. So first of all, the vOLTHA core itself needs to know that, because it needs to tell one of the two remaining cores to pick up the work that the third core is doing. But the proxy also needs to know that to change its list of round robin to remove the dead core, because otherwise, requests are going to go to a dead core that can't respond. So the longer it takes for the state change notification on a key to reach these containers, the more chances are that you're going to end up in a hung state because you've made a request to a non-existent IP address, right? The container's gone down. So choosing a KV store that responds very quickly on state change is a bonus, because there's less of a window of opportunity where you end up with a race condition that causes the problem. So that's the set of stability and HA enhancements that we're making. So how do we improve? How is this improving restart in HA scenario? So it looks like you've got a weekly status call or staff call coming up there, Sean.
Yeah. Okay.
We're seeing all your private stuff.
I know.
Okay, so the having stateless containers helps HA scenarios, because you can go to any container and ask for a response, because they're stateless, so it doesn't matter, right? You can ask any one of them, and the split brain issue from a restart perspective has been solved using Kubernetes and etcd. The one I explained earlier, which was the velocity of a state change notification, is also being improved. So overall, you're going from a fast failover with a lot of daemons hidden in the restart scenarios and the notification scenarios to one that is a true HA and has a lot less opportunity for race conditions that might cause the system to hang.
Okay. So for instance, if we talking about the OMCI, right? There's a state associated with the mid itself, and mid changes that occur because alongside messages go down to an ONU. And the OLT side of that, in vOLTHA, updates its sync value every time a change occurs to match what the ONU has. So would that be something that ECCD would synchronize to the other instances that are managing that ONU, that OLT pair, or?
Yes, so you'd want to store that information in the KV store so that your container is essentially stateless or can recover its state. Let's say it's not stateless because it's keeping all the data internal to not have to make a query onto the KV store every time it needs the value. But it is virtually stateless because it can recover all its information from the KV store if necessary.
And that was also why that I was saying that ME database that you showed inside the OMCI block did not belong there.
Yeah,
because it's not stateless. You
yeah.
take it out.
Yeah. So yes, that's theoretically where you'd want to put the data. And if it's just keys and values, then the KV store. If a different database technology is required, and I think during the NetConf discussion, there may be a highlight. We may highlight that there's a requirement for different database technology. Then there might be choices as to where you store your information.
And I think so. It's, let's say I have to send like 50 OMCI messages to create a service down to an ONU. Well, then this value of this sync attribute is going to be changing pretty fast. Is the transition from one value to the next gated by some?
So let me ask you a question. Are you going to change the value every time you send an OMCI message, or are you going to wait till they've all been sent and then
it's supposed to match what it? Well, it's supposed to match what the ONU.
Well, you'd also have to save off the change number, so that will change.
So there's a lot of values that are potentially changing fairly quickly.
Well, again, we have to decide whether you want to use the data sync or maybe audit, or what mechanism you're going to use to keep the ONU and the OLT view of ONU data. But yes, with every request that you send out, that's been accepted by the ONU, the ONU increments the council and after ONT. So we would like FPD to be performant.
Right. Yeah.
Because these KV stores are not just for databases, right? They're also used for state.
Mm-hmm.
And I guess maybe for state we could also look at a NoSQL sort of a base. I'm not sure.
I mean, if you're updating and committing essentially a change on each message, there's latency and throughput issues you have to deal with. And the question is, if you did not update that in every state change and had to replay those messages, what is that, right? So you can decide what is actually, where do I actually have to do that kind of sync versus, yeah, I can keep that in memory, for instance, but if I lose that state, who cares? I just replay and I get back to where I need to be.
So on a switch over, right? Yeah. At that point, you're going to have to say, okay, do I do a big sync all over again, right?
But you can figure out where those checkpoints, milestones are that are required, right? Versus are which I can replay.
Yeah,
right.
Yeah. But I think when you're talking about a single ONU, might be more when you have multiple using ports out there. But once you come up and you're in a providing service, I don't see a lot of data change drastically.
That's right. Once the provisioning is done and you're out of save,
so that's why I asked whether you want to do it on every message or whether you want to wait till you've done them all and then shoot one transaction into the
So I guess we have to think about performance.
I think where you
the problem is that the ONU does it on every message. So if you don't, you're not in sync at all.
I think a key value store might be a little bit faster.
I'm sure. I'm pretty sure about that.
The model we're after, right? Eventual consistency, absolutely. You have to look at that and decide what design point we're trying to hit, because we can always design the system so that there's no database in the world that can keep up with the transactions based on messages, right?
Like Turtle, MCI is definitely slow, so I think.
Yeah, you might really.
I mean, it might also be based on the service. If it's residential low-cost internet, you might be able to hit, suffer the hit when you're coming up on new ONU as opposed to business service. And make the business service take that lead.
So I'm going to play a devil's advocate here, right? With all these container and everything to support HA, we're talking about very big. Is that a big package when the people need to install things like that? I don't know what does it mean to service or to operation or service provider when they install this VOLT software.
Wouldn't change. It's in the container. I don't know what you mean.
No, what I'm saying is
Memory and disk space.
Yeah, and what we're proposing, right, is that they don't have to build an installer or anything, right? The containers are going to be in Docker.io or some registry somewhere, and basically you install the containers directly. And there's a lot of containers in HA because there's 3 servers, 5 servers, 7 servers, right? So each one of them replicates containers, but the fact is that just because the containers are replicated across all the servers doesn't mean that it's more, they're different. It's the exact same container that's just being populated on 3 different servers, right? Or 5 or 7 different servers. So, but it's the nature of microservice-based architectures is you make containers do one thing really well, and you make them as stateless as possible. So you end up with more of them, but theoretically, that improves the robustness of your system. It improves the resiliency of your system, and it facilitates the upgrade of your system because you can upgrade a single container to solve a bug without suffering any downtime, as opposed to bringing down a big monolithic Java application and restarting it because you've had an issue.
But would that be a troubleshooting issue?
Troubleshooting microservice environments are always an issue.
Okay.
How do you transaction logs across 20 containers? That's another issue. Has to be addressed.
Yeah. Are we addressing that today?
You've got log consolidation, but that's not all of it.
Yeah. So log consolidation using FluentD is one of the approaches, right? So all the containers should be logging to FluentD.
When you're looking in a cluster mode, it's a little difficult to log consolidation. I don't know how much. It's not that easy. I mean, you need to have a much.
If you're looking inside the containers, it's not that easy. But if you're looking at the consolidated log, it actually tells you which container is issuing the log, right? So you have vCore 1, vCore 2, vCore 3. They're all reporting their log. So you know which of the 3 vCores is actually telling you there's an issue. Part of the problem is that Kafka isn't logging to fluentd, right? So if you end up with a Kafka issue, you have to actually look in the Kafka containers to realize console is not logging through fluentd, right? The only things that are logging through fluentd are the things that we bring, and not necessarily, unless the software package allows you to specify the logger, right, which some of them do. You can say, you know, I want you to use fluentd as the logger, and not all of them do that. So yes, it can be a pain in the ass. But hopefully we'll write it robust enough that you don't have to spend a lot of time troubleshooting. At least the service providers don't. We may go through the headache during the testing phase, but once the service providers get it, hopefully it'll be.
They want to code.
They want. You're right.
Loves their job security.
Any questions? Do we have a so Ken have entered a few Jira tickets already, and Julie, do I think so? When we reviewed that the other day, we thought, you know, so I guess we closed 1.2, so now we're entering 1.3, and then Sprint 1 will start. Okay, so at some point, maybe the priority of all the stories already entered, and assigning to which sprint, probably those. I think Kubernetes will probably, those are the what I'm trying to say, already created on the Epic, and already created in the user stories. So that's something, probably some of them you already done it, and then so we want to march forward. So we do want Ken to start thinking about the sequence of the event and which one to be delivered first.
Right. That was something we touched on briefly on the call yesterday as well.
Okay.
Is we have these existing stories in there for Kubernetes, which you've got a good start there, but figuring out which ones should go in Sprint 1, and ideally, so we could have something demonstratable at the end of Sprint 1 as well.
And I also would like to have the community to think about is, you know, I guess, you know, we appreciate Sienna taking this as a lead, and then you guys working on the software side. But I think also, I'm sure you welcome other people to contribute too. So
don't want anybody home.
We're
okay.
There's a question again.
Dinasti?
Hi. Let me try to make general, observations. The 3 bullet items, starting with the disaggregation of vCore into specialized services and separating global data from per instance data and new stateless containers for read-only requests. So when I look at these, it seems like by basically breaking the vCore into specialized services, this is kind of like heading towards the microservices model. And so, right or wrong, I'm going to go ahead and ask the question. So in my mind, that requires you splitting your domain into multiple domains, one for each specialized service, and also looking at the separation of global data and the read-only requests. So you're also seems like heading towards CQRS, command query responsibility segregation. So the one definitely question comes to mind is that when it comes to basically reconstructing the state by reading the values or events specifically from a KV store, have you given a thought, perhaps for a middle-of-the-road case, like how many basically events you will be reading and in order to reconstruct a state?
So for read-only containers, you don't really need to reconstruct state, right? Because
correct. You are separating that, as I said, not for read-only. There's a reason for having it read-only, absolutely. But I'm sorry, one more thing. I apologize for interrupting you. In addition to basically breaking your domain into domain model into multiple domain models because of services, CQRS also forces you to break your split your domain again, one domain for read-only requests. Because if you're going to use the exact same store for both read-only and state-changing reconstruction, you're not basically gaining much performance. Go ahead.
So no, we're using the same KB store for read-write and read-only. What we are not using for read-write and read-only are the actual Docker containers themselves. They're going to go to the same KB store, and at this point, I don't anticipate performance issues, but some extensive testing needs to take place depending on how many or what the size of this database is going to end up looking like once this is in production. For the read-write containers, you are correct. The container needs to reconstruct its view of or its state from the database, but that's okay because the read-write containers are actually duplicated and paired, and it's the peer of a read-write container will be running on a different server than the primary. Actually, they're active, but I don't want to get into that right now because this could spiral into a rat hole that could chew up 2 days. But the read-write containers are peered. So that means that if one of them dies while it's busy coming up and reconstructing its state, its peer will take over the requests and be able to perform them on the container pair behalf. So theoretically, you should take no hit. From an end user perspective and an API and a request perspective, you should see no difference, whether a container is down and restarting or not. The worst case scenario, if 2 servers goes down, you're in trouble anyway, because in an HA scenario, you should never really lose 2 servers out of 3. So does that answer your concern?
Yeah, sure. Thanks.
Okay, so are you reconstructing state from the database, or you're reconstructing it from your peer?
So you're reconstructing state from the database. The database should be in sync. Even the peer communication for message handling and everything else is through the database. So one of them will grab this. It's a race condition to grab a lock to say, okay, I'm going to handle this request, right? Because they're both getting the same request. So one of them will grab a lock and say, I'm handling the request, so the other guy just lets it go, right? He doesn't need to handle it. That's the intent. Now we still need to go through. There's a lot of details we need to work through on that because it's never simple when you've got two potential containers that are going to be handling the same or getting the same request, and making sure that only one of them processes it. And they don't both try and process the same request because that could be messy.
And I guess those will be the details will be the use cases, and then everybody should give something.
So we're going to. This is a very high level view of what we're doing, right? It's a PowerPoint chart. There's not even an architecture in here at this point. At some point, we'll have both an architecture chart and then a more detailed architecture chart with the sequence diagrams on how things get handled and how the communication is done through. And there is a bottleneck, right? I mean, you need to communicate through a common mechanism. The common mechanism today is going to be the KB store for locking and making sure that things are kept in lockstep and in sync. But I think the performance hit of that is a lot less than anything else that's
in the call chain, specifically in dealing with the requests as they go southbound. So I'm not too concerned about the performance hit.
So just one more minute. So, on the stability enhancement, we thought that for the vOLTHA 2.0.
Yes.
Right?
Yes.
So are these all going to be done? I mean, you're probably going to start, it will be part of 2.0's release, but not
we've already started a lot of these, right?
Right.
So, but they're only going to be done by release 2.0. So once we start tracking sprints for 2.0,
okay,
we'll start inserting user stories. Some of them, we might get an immense number of user stories done in the first sprint because they're already all done by the time we get there, right? So for example, Kubernetes migration is a 1.3 effort. The use of etcd is probably going to be done by 1.3,
yes,
right? So, but the intent is that all this will be complete by 2.0.
Okay.
So as a whole, the idea is to get all this done by 2.0.
Okay.
If stories are done in 1.3, they should be as JIRAs in 1.3 and marked as completed.
They won't be submitted though. They'll be done in 1.3 but not submitted. They'll be in a working in a staging area that we're doing testing in.
Right, not going to be in master.
Exactly. They won't be submitted. They're not going to be anywhere other than in a local repository. Right.
All right.
They'll end up in master as of 2.0.
Okay. I think that's good.
But yes, I agree with you. If we were submitting them to master, they should have been in 1.3. Yes.
So I'm going to stop. We're 5 minutes past, so we end this morning session. Thank you very much. Thanks, Sergio, for the very informative discussion.
And Ken as well.
And Ken,
he gave a lot more detail than I did.
Ken, sorry, I didn't turn
No problem.
So I'm going to stop the recording now. But AT&T has a cafeteria down in the lower level. If some of you have not maybe follow the one who knows where it is. I'll be here, so in the room, you can leave your stuff here. We'll resume this afternoon's meeting at 1 o'clock. Thank you very much.
Okay.
You broke your key cards.
That's the one from like years